Hello everyone and welcome to another video with Special Maths Academy. In this video, we'll be looking at the eighth problem from the Special Maths Contest, SMC, um, 2024, the first round. And it says, ABC is an isosceles triangle with angle ABC being equal to 120 degrees. ABGH and CBIJ are squares constructed on the exterior of the triangle ABC. So what is the value of angle HJG plus angle HIG? Okay, so let's look at this. So first of all, we're given an isosceles triangle, but we're not told the two sides that are equal. But we can infer this. So an isosceles triangle has two angles being equal, the base angles. So it's very obvious that the base angle cannot be 120 degrees. Why? Because we have that 120 degrees. So we have two angles being 120 degrees. The sum of the angles greater than, will be at least 240 degrees, which is greater than the sum of angles in a triangle. Okay. So it means the base angle is not going to be 120 degrees. So we can sketch. Okay. So I have ABC. So we have 120 degrees. It's equal to this. Okay. Then we have to construct, we have to rather sketch these squares, ABGH. So we have to pay attention to the order of the alphabets. So it's very, very important. So ABGH. So AB, so GH. So we have 90 degrees on the square. So since it's a square, and then we have CBI, so this point. So let me erase this equation up here. Okay, so erase this equation up here. That's this purpose. So CBIJ, it's also a square, so we can mark all these side lengths equal. And then we want to find the sum of the angles HJG. So HJG. And HIG. Okay, so that's so I want to find the sum of this angle. Okay, so let's look at this and see what we can get. So the first thing we can see is that since ABC is isosceles, and we'll be able to see that 120 degrees is not going to be the base angle. So we have that the angle BAC and BCA are equal. So these two angles are equal. And to calculate it, we just have to do 180 degrees minus 120 degrees divided by 2. So this will be 30 degrees, 30 degrees. So we know that the base angles are equal. Okay, so you can confirm that this, adds up to the sum of angles in a triangle, which is 180 degrees. Next, which is crucial to even the points in the end result in this problem. So we can find this angle at angle GBI. Okay, so we have angle. Okay, so let's see some of angles at the point. So angle ABC plus angle ABG plus angle CBI plus angle GBI. This is equal to 360 degrees. So ABC is 120 degrees. ABG is 90 degrees, of course, because of square. CBI is 90 degrees. Okay. Plus angle GBI. This is 360 degrees. And when we add this 120 degrees plus 90 degrees plus 90 degrees, this gives us 300 degrees plus, okay, angle GBI being equals to 360 degrees. So basically we can get that GBI is 60 degrees. Okay. So I'll just put 60 degrees here. Okay, cool. So what next can we get? Okay. So we can look at triangle GBI now. So we have triangle GBI is isosceles at the moment. So we have BG being equal to BI. Okay. So we can calculate the base angles. Okay. So the base angles can be calculated. Okay. And the base angles, so we have angle BGI is equal to angle BIG is equals to, so just subtract the angle at the apex, so 180 minus 60 all over 2. So this is equal to 120 divided by 2, 120 degrees divided by 2, which is equals to 60 degrees. So rather, these two base angles are 60 degrees each. So this 60 degrees, this is 60 degrees. Okay. So what does that imply? It implies that BGI is equilateral. Okay. So the next important step, so I'll just put it here. Triangle BGI is equilateral. Okay. So since it's equilateral, it means we can mark this GI, to be equal. So now, since GI is equal to this other line segment, which you had to be equal, of course, from the square and the isosceles triangle, it means we can say, so this implies that triangle HGI is isosceles. Okay, and of course we can find the base angles. Okay, so here what we can do quickly, we can see that so let's just look at it. So the angle at the apex, angle HGI is equals to 90 degrees plus 60 degrees, so that is 150 degrees. Okay. So this whole angle here is 150 degrees. So now we can find the base angles. Okay. So to find the base angles, we just have to do 180 degrees minus 150 degrees divided by 2. And this should give us 15 degrees. Okay. So this angle here is 15 degrees. This angle here is 15 degrees. Okay. So basically angle HIG is 15 degrees. Okay. So we found one of the angles that we want to solve. Okay. What else can we get here? So now, a major challenge would be to find angle HJG. Okay, but then to do that, we can also observe that angle. So we can observe that angle GJI. So scroll down. So let me erase this. Okay, so we have triangle GIJ is also isosceles. And of course, um, as before, the angle at the apex. So GIJ is 90 degrees plus 60 degrees, which is equals to 150 degrees. Okay, so it means the whole angle at the apex is 150 degrees. So it means we can find the base angle. So this is going to be, so we can find this quickly. It will be 15 degrees. So as before, similar to the last triangle. That's actually congruent to the last triangle, and this is going to be 15 degrees. Okay. So what can we see immediately? So if you look at quadrilateral, so look at quadrilateral GHJI. Okay. So we have that angle G, so angle HIG is equal to 15 degrees. We have angle GHI also equals to 15 degrees. And we have that angle GJI is also equal to 15 degrees. So we have angle GHI and angle GJI as both 15 degrees. So what does that tell us? It tells us that this is a cyclic quadrilateral. Okay, so this equality here tells us that it's a cyclic quadrilateral. Okay, so since it's a cyclic quadrilateral, it means we can quickly get some things out. So we can see that. So let me erase this. Since the cyclic quadrilateral, we can get that angle H, so angle subtended by same chord. So angle HIG is going to be equal to angle HJG. So which is already 15 degrees. So after these two angles, we want to sum up at 15 degrees. So 15 degrees plus 15 degrees gives us 30 degrees. So our answer is going to be option C, 30 degrees. Okay. So actually, of course, there's a bigger picture here. There are a lot of things you can consider as well, but this was an interesting problem to, get our hands dirty with cyclic quadrilateral, circle theorems. Okay, so that'll be all for this video. And I hope you enjoyed it. Feel free to like, share, comment, subscribe. And if you have any questions, we'll be waiting for you in the comment section. So see you in the next video. Goodbye.